Hello, welcome to Chapter 8, Section 2. In this section, we're going to be factoring polynomials by the GCF, which stands for the greatest common factor. Now, the last thing you remember us doing probably, unless you're watching these out of order, is we were multiplying polynomials and ending up with a product. What we're going to be doing now is called factoring. And factoring is kind of like unmultiplying. It's not exactly the same as dividing. Dividing means that I'm going to, I know two things multiply to give something, and I'm going to give you one of those. Okay, so let me do it with some numbers, not with polynomials, okay? So let's talk about multiply. If I multiplied 3 times 4, I know that that's going to equal 12. And we can do divide. We can do 12, but then I have to tell you, what am I dividing 12 by? Well, let's say 12 divided by 3. That equals 4. Now that's all like elementary school arithmetic. But now here's where it becomes middle school arithmetic and starts to lead into high school algebra. If I say factor the number 12, then one of the choices could be 3 times 4. And actually, if I threw in another word and I said, I want you to completely factor 12, then it would be 3, but 4 would be 2 times 2, because these would be prime numbers, which means they cannot be factored any further. All right, now that's like the arithmetic part of it. So what are we doing now? So you learned in a previous lesson in chapter 7, that if I multiply x plus, I'll give an example here, x plus 2 times x plus 5. And we talked about how to do that. I mentioned doing it with a multiplication chart. Some people call that the area model. But either way, I'm going to end up with this: x squared plus 7x plus 10. If I go backwards, this is called factoring. So I'm going to have a polynomial, and I'm going to break it into other polynomials to see what I actually got. This skill shows up in many places. We're going to be working with different types of factoring in Chapter 8. The next time you see factoring will be in Chapter 9, when we factor to solve quadratics. For example, this one right here, to the second power, is a quadratic. Okay? That's not. That's to the third power. This is a quadratic, and so is that. Factoring quadratics helps us understand things about quadratic functions. They're called the zeros. And these are related to quadratic equations, and factoring helps us find things called the roots. Zeros of the graphs, roots of the equations, but they're the same thing. Just depends whether you're talking about a function or an equation. And not only that, but when we get to problems like this, even though that's not quadratic, this is a cubic. If this was a function, it starts with y, but if I said f of y equals this, then this leads us to more advanced math, which if you stick with it and end up in pre-calc, you're going to be seeing a lot more of this, okay? It gets to the idea, and then I'll get to work so you can see how to do this, but this is just one of those places where I wish you could see where you're headed, because this gets to something that's called the fundamental theorem of algebra. And when it's called the fundamental theorem of algebra, that means it's pretty important, right? But in this video, I'm not going to get a chance to talk about that. We mention it a little bit in Algebra 2, and then pre-calc, they spend a lot of time with that. We are going to factor by using the greatest common factor. And what's the greatest common factor? So here's how we're going to do it. 4x to the second power, I'm going to break this into primes, and I'm going to split out all the x's. So 4 is 2 times 2, those are both prime numbers, and x to the second power is x times x. I'll put the subtraction there. We may have to come up with other ways to do the subtraction. 3 is a prime number already. And of course that just means 3 times x. Now I've separated everything with the multiplication dot just to make it a little bit easier. What I do is I look here and I look here. I look at, these are called the terms. I look here and I see that here's an x and here's an x. I have a 2 here, but there's no 2's over here, so I'm not going to circle that. I have a 3 here, but there's no 3's over here, so I'm not going to circle that. I have that x, but I've already shared that x with both of these. So the common factor, the greatest common factor, is just x. I'm going to write that. I'm going to put parentheses. And what got left here? 2 times 2 times x. That's 4x. What got left here? Subtract 3. And that's it. So this is like the opposite of distribution. We talked about distribution in the previous section. This is the opposite of distribution. It's just distribution backwards. And we're trying to figure out what got shared with both of these that I can bring out, and that's my common factor. Let's do this one. So I'm going to do the same thing. 10 is 2 times 5. Y to the third power, 1, 2, 3. Y times y times y. Plus sign. 20 is 2 times 10. 10 is still 2 times 5, so I'm going to make sure I go all the way down the primes. Y to the second power is y times y. And for the third term, subtract, and again, that may cause problems later, but for right now it's okay. 5 is prime times y. All right, what do they all have in common? And when I say they, I'm talking about the terms. What does 10y cubed, 20y squared, and 5y all have in common? They all have a 5. So I'm going to circle that. Here's a 2, here's a 2, but there's no 2's over here. So if I didn't have this part, I could also figure out that both of them have a 2, and that could be a common factor. But I got to take care of all 3. It has to be in all 3 terms. So I got to leave the 2 alone. So now I start looking at the y's. Here's a y, here's a y, and here's a y. Again, I have more y's here and another y here, but I'm all out of y's in this last term. As a matter of fact, I've taken everything from that last term. I wonder what that means. So my greatest common factor, my GCF for this one, is 5 times y. And I'm going to write that out in front. What got left here? 2 times y times y. That's 2 times y to the second power. What got left here? 2 times 2 times y. 2 times 2 is 4 times y. So that's 4y. And what got left behind here? You think, well, you took everything. You took the 5, you took the y. Nothing got left behind. Well, when we're talking about multiplying and factoring, nothing is not 0. Nothing is 1. Because I can always multiply by 1. And I've shown you before, sometimes multiplying by 1 is very, very useful because it's the hidden 1. So I know I can multiply by 1 there. So what got left behind? Minus 1, or subtract 1. I gotta stop saying minus. All right, let's look at this one. I'll move it up so you can see it. Negative 12x. So the negative is that negative 1 we were just talking about. 12 is 2 times 6, which is 2 times 3, all primes. And then, of course, I have an x. Here's that negative again. And I said it's gonna cause some problems later. All right. I'm going to add negative 1, because I got negative 1 there. I'm thinking ahead. 8 is 2 times 4, which is 2 times 2. And x to the second power is x times x. So now, by changing that subtraction to adding negative, I have a common factor of negative 1. That'll be useful. Here's a 2. There's a 2. And this time there's another 2. I have a 3, but there's no 3's over here. I have an x. I have an x right there. And it didn't matter which one I pick. It doesn't matter. This 2, there's no more 2's over here. And that x, there's no more x's over here. So my greatest common factor is -1 times 2 times 2 times x. That's -4x. Now I'm going to write my parentheses. What got left behind here in the first one? Just the 3. What got left behind in the other one? Put the plus sign down. 2 times x. All right. Last one. 5 is already prime. X squared is x times x. Don't have to worry about any silly negatives. I got a plus sign. 7 is also prime. Maybe I can even put 7 times 1. Here's a 5. There's no 5's over here. Here's a couple x's. There's no x's over here. Here's a 7. There's no 7's over here. Aha! The greatest common factor is 1, because I could also put a 1 over here. If the greatest common factor is 1, multiplying by 1 doesn't change anything. So you just leave it. Just write 5x squared plus 7. That one, we can also say there is no, I like to say this word, non-trivial, because 1 is always a common factor, the number 1. So it's trivial. So there's no non-trivial or greatest common factor that's not trivial for this one. And actually, these two terms, there's another word for it. They're what we call relatively prime. But that's not going to be on a test. That's just for me teaching you. All right. We'll see you in the next video.